In today's video, here is a nice problem regarding function equation. So our goal, we are going to determine P of x satisfy this following equation. We get x minus 111 is multiplied by this function P of x plus 3 equals x is multiplied by B of x. So our goal, we are going to determine P of x based on this information that we have here. Okay. So you guys, you can give the hand to this problem pre to session. Go ahead, pause video when we come back to see for session. Okay. Now let's get started. So notice here, before we get started, always we are going to give x equals 0 to make the right hand side of this equation equal to 0 because you get x here. Okay. So if x equals 0, which means I get 111 is multiplied by P of 3 equals 0. Okay. So let's do that. So we get x equals 0 is going to give us P of 3 equals 0. It's more simple because it equals 0. Another thing we are going to notice here, we know 111 equals 3 is multiplied by 3 is multiplied by 37. Why we need that? Because we will have a nice relationship between this number 3 and 37. Okay. If you take a look at here, we get number 3 here, we get 111 here. Okay, which means 111 is going to be written on the form of 3 is multiplied by 37. So so we get P of 3 equals 0. Another observation here, I'm going to calculate P of 6. Okay, so I'm going to do that. I get P which equals P is multiplied by 3 is multiplied by 2. Okay, so we are going to prove this one equals to 0 as well. So how we do that? So simply going to replace x with 3. If I'm going to do that, I guess x equals 3 is going to give us here minus 08 is multiplied by P of 6 because we are in number 3 here. Okay, so which equals 3 is multiplied by P of 3. We know P of 3 equals 0. This one implies P of 6 equals 0. So this pattern is going to be all the way down like P of 3 is multiplied by 3 is going to be all the way down. P is multiplied by 3 of n which equals 0. Okay, so we are going to do that by induction hypothesis. So suppose we get the base case P of 3 equals 0, which is true. Now let's suppose P of 3n is going to be 0 as well. Okay, so this is our goal. We are going to prove this one, which means we are going to prove P of 3 is multiplied by n plus number 1 equals 0. Okay, so we are going to start with this one as a true assumption. We get to arrive here. Okay, so before we do that, we are going to fix n is going to be between number 1 and 36. Okay, why we do that? I will tell you in 1 second why I choose n between number 1 and 36. Okay, so I'm going to replace, now we are simply going to replace x with 3n. Okay, let's set x equals 3n. Take this value of x and insert it back into the original equation to see what's given us. Okay, it's more simple here. We get x, it will be replaced with 3n. We know 111 is going to be replaced with 3 is multiplied by 37, like this. Then taking this 3 as a common factor here is multiplied by P. X will be replaced with 3n. I'm going to take number 3 as a common factor here. So we get 3n plus number 1, which equals 3n is multiplied by P of 3n. So based on the assumption that we have here, P of 3n equals 0. Okay, so here is a thing here. Since we get n between number 1 and 36, never ever get 0 here. Okay, between this difference is going to be different than 0. Okay, based on this condition that we have chosen here. Okay, if this one is different than 0, this one equals to 0, which means this one is going to be 0. Okay, which means we have proven this case. So we have proven P of 3n plus number 1 equals 0, which means our assumption is true, which means we have proven this one. Okay, now let's get rid of this one and move on to the next step. Previously we have proven P of 3 equals 0, P of 6 equals 0, and all the way down to the P of 3n equals 0. Okay, so in particular we get P of 3 is multiplied by 37 equals 0. Okay, which means these values 3, 6 and 3 is multiplied by 3 all the way down 3 is multiplied by 37 are the roots of this polynomial. Okay, so in the other word, I'm going to write this one on the form of P of x is going to be written on the form of x minus 3 is multiplied by x minus 6 is multiplied by x minus 9, and all the way down to the x minus 3 is multiplied by 37 is multiplied by another function. Let's call it q of x. Okay, why this bunch of this product, why this bunch of this number making this product including q of x? As we know 3, 6, 9 all the way down to 3 is multiplied by 37 are the roots of this polynomial, which means it's going to be written on this form. So I am adding this one because always you get a function, always is going to be multiplied by another function. This function could be a function itself, or it could be a function itself without any roots, because all the roots that we have were extracted on the form of the product, including this one without any roots. It could be a function, is going to be positive, or a constant. Okay, so this is what going to be happening here. So we are going to identify this function. We want to know about this function. Okay, q of x. So how to do that? I'm going to replace x with x plus 3. Okay, so I will have P of x plus 3. If I'm going to replace x with x plus 3, is going to be, we will have x here. This one becomes x minus 3 because always you subtracting number 3 here. Okay, so this one it becomes x minus 6, and all the way down this one it becomes x minus 3 is multiplied by 36. This one becomes q of x plus 3. Okay, so in order to transfer this one on this form, we are simply going to multiply both sides of this equation by x minus 111. Okay, let's do that. I get x minus 11. This one also is going to be multiplied by x minus 111. Okay, so which means the whole left hand side of this equation is going to be equal x is multiplied by p of x, which means I will have x is multiplied by p of x is going to take this product. Okay, which means x is multiplied by x minus 3 is multiplied by x minus 6, and all the way down to the x minus 3 is multiplied by 36 is multiplied by q of x plus 3 is multiplied by x minus 111. Okay, we know x minus 111 is always is multiplied 3 is multiplied by 37. Okay, it's more clear. Also, we are going to replace p of x with this product. Okay, let's do that. So I get x is multiplied by these things. I get x is multiplied by x minus 3 is multiplied by x minus 6 is multiplied by x minus 9, all the way down to the x minus 3 is multiplied by 37 is multiplied by q of x. Okay, equals to the right hand side of this equation. Right hand side of this equation is going to be x is multiplied by x minus 3 is multiplied by x minus 6, and all the way down to the x minus 3 is multiplied by 36 is multiplied by q of x plus 3 is multiplied by x minus 3 is multiplied by 37. It's more clear. Okay, now we will have a lot of cancellation between the left and the right hand of this equation. So we get x, this x is going to be cancelled with this x minus 3 will be cancelled with this x minus 3, this one is going to be cancelled with this one is going to be cancelled with that one after this one, all the way down, and also this x minus 3 is multiplied by 36 is going to be cancelled with that one before this one. Also this one, it's more clear, is going to be cancelled out with this one. What we left with, I will be left with q of x equals q of x plus 3. Okay, it's more simple. So I get q of x is equals q of x plus 3. So this is the important thing that I have extracted from this equation. Now let's take this equation at the top and continue solving up and continue working on it. So previously working on this equation and came up with this nice result. So get q of x equals q of x plus 3, which means this one is going to be a constant anyway, okay? Because you get something, you can add anything on it. You get a function x is going to be add anything you want, is going to have the same image, which means the function is going to be a constant, okay? So let's keep adding number 3 each time. So we get q of x, which equals q x plus 3, and this one is going to be add another 3, which is q x plus 6, which equals q of x plus 9, and all the way down is going to be q is multiplied by x plus 3n. So we will have the same thing if I'm going to start with x plus 3 and keep subtracting number 3 all the way down. So we get q of x plus 3, which equals q of x, which equals q of x minus 3, which equals q of x minus 6, all the way down to the q of x minus 3n. Okay, so what happened here? So we get a bunch of the values, which is going to be a multiple of 3, okay, equal the same thing, okay? Even though if you are going to subtract each time number 3, at the end you get q of x plus 3n equals q of x minus 3n, and equals q of x equals q plus 3, or whatever it is, okay? So this means the function is going to be a constant. If you are going to check the function, this is all the values that we have as a inputs. So for example, you get this function as a constant function, as a q of x. So this is the values. We get x plus 3, this is x plus 6. So we will have the same output for each one, all the way down. If you have x plus 3n, okay? So if you are considering n as a natural number, okay, whatever it is, even so we will have the same thing as you go into in negative direction. You get x minus 3, x minus 6, and all the way down you will have a constant function always, okay? This is what happened here. So since we get q of x equals q of x plus 3, which means this one is going to be a constant. It's going to q of x is going to be replaced with lambda, okay? So we get a function p of x equals this product, which is x minus 3 all the way down to the x minus 3 is multiplied by 37, is multiplied by lambda, which is a constant, okay? Which is this one. So now I have ended with this video. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. We'll see you next video. Bye.